Thank you and welcome everyone to today's webinar, Gas Absorption Heat Pumps, Best Practices with FortisBC. Really excited to have you here today and discuss this new technology and FortisBC's approach. So a little housekeeping before we get started. The best way to listen to, you can use your computer audio, headset, is recommended. If you're having any issues, there's also a dial-in option. You'll see that in the audio panel. We are going to have lots of time for questions and answers today, and we want to hear from you. So type your questions as we go along into the questions box, and we will weave those into the discussion at the end of today's presentation, which is being recorded, and each of you will receive a copy of that recording at the conclusion of today's event. And so with that, I'm going to turn it over to Ted Baker, who's our Senior Conservation Account Manager in the commercial industrial space in Canada, and he's going to be our moderator for today. So Ted, I'll turn it over to you.
Very good. Thank you, Nick. I appreciate that. Yes, we're in cool and chilly Toronto. Myself, we've got my fellow panelists here, Saleh, who's in beautiful Vancouver, British Columbia, and Ali, who is in Calgary, Alberta. So you've got a full Canadian contingent on the call, and some fine-looking gentlemen, I might add, on our great pictures here. But our session today is, we'll go to the next slide if we can. I'm just going to jump into our overview of what we're trying to accomplish today. And we've broken this session up into 3 distinct themes. So to help the audience understand, I guess the first theme is how Fortis got to this place and why they're supporting this technology. We're going to move then into the technology itself, give a high-level overview, and you've got one of the leading experts of the technology, Ali Abbas, and we'll let him explain more on that. And then the final is the actual journey that Fortis has been on for the last few years, and projects, successes, lessons learned. And as we're going through, I encourage you to flip through or add your questions as you're doing this, because I'll be able to sprinkle those in and ask the right questions of the right panelists to see and when it's appropriate in the subject where we're currently working. So at that point, or at this point, I'm going to move over to the first theme of this journey, and I'm going to turn it over to Saleh Levy and let him introduce himself and give everyone an overview of the FortisBC. Go ahead, Saleh.
Thanks, Ted. Good morning, everyone. Good afternoon, depending where you are. Saleh Levy here. I'm the program manager for commercial industrial program areas in the Conservation and Energy Management Department at FortisBC. And I'm here to share FortisBC's story with gas heat pump programs, incentive programs, particularly with a focus on gas absorption heat pump technology. A little bit about FortisBC. So we are Canadian-owned, British Columbia-based utility, both gas and electric utility, with more than 2,500 employees across the province in Canada, with 100 years of experience in delivering energy. So for folks who may not be very familiar with Canadian geography and province of British Columbia, we are on the Pacific coast, most western side of Canada, and to the south of British Columbia is state of Washington, and we're located southeast of the state of Alaska. So that's where we are. FortisBC is both a gas and electricity utility in the province. We deliver natural gas and electricity to roughly around 1.2 million customers in 135 communities and 58 Indigenous communities. And as an energy delivery company, we own approximately 50,000 kilometers of natural gas pipelines and more than 7,200 kilometers of electricity transmission and distribution power lines. I want to talk to you and share with you a little bit about what we are doing to support our customers in British Columbia decarbonize. So we've created 4 pillars of clean growth pathway, and I want to give you a little bit of explanation and information about that. So on the first on the right hand side, the first pillar is liquefied natural gas for marine fueling and export to global markets. Essentially, that is marine bunkering and providing liquefied natural gas to vessels and ships in the province and help them convert from diesel to liquefied natural gas. That's one way of decarbonization for us. The second pillar is investing in electric vehicles and low carbon transportation. So Fortis is an electric utility as well. So we heavily invest in EV chargers and EV electric vehicles and CNG, LNG for transportation. The third pillar, which is really expanding on our end as well, is the renewable and low carbon gases. So we invest a lot in biomethane creation and production from wastewater treatment facilities, agricultural waste, municipal solid waste, landfills to capture that biomethane and inject that to our pipeline. So that way customers can receive that renewable gas, low carbon fuel from us through the pipeline. And we currently offer different blends, 10%, 15%, 20%, all the way to 100% of blend of renewable gas. And that's an important pillar for us in decarbonization. And the fourth pillar, which is really my area, is energy efficiency, really helping customers reduce their natural gas and electricity consumption by way of energy efficiency and conservation. And that's the fourth pillar that we're supporting our customers in their decarbonization journey. So a little bit doing a deeper dive into that pillar and focusing on commercial industrial programs. I just want to give, before we talk about gas heat pumps and gas absorption heat pump, wanted to give you a lay of the land and sort of more information about other products and offers that we have out there. So on the gas side, we do have product rebate offers, or we call them prescriptive offers, for hydronic boilers, water heaters, gas kitchen appliances. We support our customers with steam boiler optimization measures, thermal curtains, and many, many more measures to help them reduce their gas consumption, for our commercial industrial customers. And we also have performance programs where we support our customers with energy studies to identify any energy conservation measures, and then on a case-by-case basis work with them to implement those measures and give them capital incentives for those measures and projects. On the electric side, same story. We do offer a product rebate or prescriptive offers as well on LEDs and horticultural lighting, refrigeration systems. Yes, Fortis provides incentive for electric heat pumps in our electric territory. We call it shared service area, where Fortis is both gas and electric utility in the province. And we have a lot more prescriptive and product rebate offers, as well as performance programs to help customers reduce their electricity consumption and provide them with capital upgrades for those projects as well.
Very good. That's a great overview, Saleh. I thank you for that. Lots of stuff. You guys have certainly been busy over the years, and I know there's a lot of changes. We'll let you get into the changes in some of the programs in our following theme, but I'm going to move into theme 2 now, which is actually the gas absorption technology. I'm going to turn it over to Ali. He has been the key figure and industry, I guess the industry expert, leading the charge in creating a best practices guide, and can help everyone understand his journey through this technology and understanding. I'll turn it over to Ali now.
Thank you, Ted, and hello everyone. So I'm engineering manager based out of Calgary, Alberta, and I support energy conservation and technology evaluations, program design assignments for a number of clients here. And I've been working on the GAHP technology with FortisBC since 2021. So certainly there have been a few learning moments along the journey, and it's very encouraging to see where things are now from where we started. Before I begin, our organizers have told me that the majority of the audience is joining us from the States. So it'll be better if I use both the Fahrenheit and centigrade whenever temperature comes in. So Nick, thank you for that. I've made my notes. So I'm just going to take a few minutes to talk about the technology. And for those in the audience, if we could stay on the previous slide, I was going to point to that picture. It shows two GAHPs that were installed outside a multi-unit residential building in BC during a Fortis pilot. And you can see somebody's balcony and a window in the background. I can't say that was intentional or part of the test, but I can tell you that there were no noise complaints. I think the sites are still running. It's been 2 years now. Yeah, so the technology, I start my conversations about GAHP with the comment that it is not a silver bullet, but it is one of the many, many solutions that are commercially available, have been tried and tested now to help facility owners make their space and water heating systems efficient. So
Ali, like through our journey, we've learned that this has been going in Europe in a lot of other jurisdictions for quite a time. Maybe you could explain that to some of the audience as well.
Yeah, so the technology has been around for, in fact, it's a cycle, and I'll explain that in the next slide, but it runs on an absorption activated cycle, not a vapor compression cycle like most of the other electric heat pumps or air conditioners. So that technology has been around for over 50 years now in the absorption chillers. And so it's the same technology. In Europe, the gas absorption heat pumps came in to the market about 10 years ago. We've been a little lagging here in North America, but it's a technology that's been around for a while.
Thanks, Ali.
All right, so if we could move to the next slide, please. Right, so this is a schematic of a gas heat pump, gas absorption heat pump process in a heating mode. GAHPs do come in a ground source or a water source to water configuration as well, but this here is a representation of an air to water system. There's a lot of standard stuff in this GAHP unit, like a burner, a gas valve, fan, pump. There's an evaporator and a condenser. But the main difference from an electric heat pump or an air conditioner is that there's no compressor here. Instead, there's a generator and an absorber at the top of the cycle, as you can see here. So how does it work? First of all, the heat is supplied at the burner to heat the ammonia water mixture in the generator. This excites the ammonia, and the vapor separates from the mixture. It goes towards condenser, and inside the condenser, it exchanges heat with the water that is coming from the NU, such as domestic hot water or space heating system. This heat exchange cools the ammonia, and it makes its way to the expansion valve, starting to condense. The expansion valve actually reduces the pressure and the boiling point of the ammonia, which then enters the evaporator, where we have free heat which is collected from the outdoor or the ambient air, and it is transferred over to ammonia, which then starts boiling, making its way to the absorber, where we have water from step one. The mixture is formed again, sent back to generator, and the cycle completes. In the cooling mode, the cycle just reverses. So it's just a very quick way of explaining what's happening. Nothing rocket science here. It's very simple and very straightforward. Next slide, please. So if you're wondering why and where do GAHPs fit, let's start with a few key benefits. These units have a high performance when compared to conventional equipment such as boilers. Even the most efficient boilers that you'll find will perform at efficiencies in high 90%. These heat pumps can perform at a coefficient of performance that ranges from 1.2 to 1.4, depending on the make, model, and operating conditions that you're looking at. So in simple terms, you're getting more energy out than what you're putting in, which is similar to all heat pumps that are available in the market. Obviously, that is not the case for boilers. Secondly, these units are easy to operate and maintain, and that's the feedback we've received from facilities that have been running these units for a while now. The maintenance requirements are very low, and it's more like once it's commissioned, it's just running. It's there and quietly running. Another big advantage is that you do not require electric service upgrades in most of the cases because the units can run on a single phase 15 amp circuit, 240 volts. So it's pretty straightforward. And of course, cold climate operation is important, especially for us in the north. The manufacturer data suggests that these units have been tested down to -20 Fahrenheit or -29 degrees Celsius. The picture that you see here is from project that was installed in Toronto. Some of the other benefits that I have not listed here, but they are also worth mentioning, like the refrigerant. It has zero impact on global warming potential, has zero ozone depletion impact. The units that burn can, in addition to natural gas, can also burn propane, can burn a blend of hydrogen and natural gas. And we've heard from some manufacturers that they're also working on a 100% hydrogen burner as well. In terms of applications, here's a list. GAHPs can be applied to a variety of commercial end users, from hospitals to buildings to schools, and the list speaks to some of them. But that said, there are some caveats to consider when installing these units. Obviously, these are heavy pieces of equipment. So if your building's mechanical room is on the roof, these units will be installed on the roof, and you will require a structural assessment before you do that. If a building heating system is designed for a high temperature loop, these may not be a good fit, as these can only produce water up to 140 Fahrenheit or 60 Celsius. And in case of cold climates, the outdoor piping may require antifreeze protection, like a glycol loop, which can take away a bit from the performance. As I mentioned, the GAHPs are a great addition to the list of many solutions that are available to facility owners for improving their system efficiencies. And yeah, if you have any questions about the technology, please put those in the Q&A box, and we'll try to answer these. There's going to be more conversation, more information coming up, and look forward to that. So back to you, Ted.
Well, before we move, Ali, and before we take off from your side of the discussion, we have a great question from Darren. But how does the COP change with the outdoor ambient temperature? What is the effect of the COP with the outdoor ambient temperature?
So it's a great question. It does go down with the drop in temperature. Oh, we have a slide here. Okay, so this was a backup slide for one of the robust GAHP A unit, as you can see, 123 MBH. So this demonstration is based on the manufacturer's data. It's not the pilot data, but it's pretty accurate and close to what we've seen in the pilots too. So as you can see, there's I don't know if I have time to go over all of it, but essentially what it's saying is, depending on what is the temperature output of the water that you're extracting from the unit and what is the outdoor ambient temperature, the performance will start to drop at a certain point. So even if you look at the for example, the red or maroon line, which is -30 degrees water output, 30 degrees Celsius water output, it goes to zero. It stays above COP of 1 even at -28 Celsius. So it's pretty substantial. If you have a water output of -60 Celsius, 60 centigrade, then at -28 your COP is less than 0.9.
It's very good. Thank you, Ali. There's one question in the question area, and I'm going to answer this one myself. And this is again through our lessons learned. Why isn't the technology being more widely adopted? And it's very obvious to us. It's not perfect in every situation, and it's not going to address everyone's situation, but it has a place in the market, but it is an expensive option. So the contractor network are not familiar with the technology. The design community is not that familiar with the technology. So all of those things add additional cost to a project when there's unknowns, when you're trying to quote a project. In actual fact, we've seen over the last 2 years, and I'm going to ask Saleh to speak to this part, they've actually seen the cost come down significantly once the contractors that are quoting the work actually understand what is needed for the projects. The designer, the design community and the engineering community, we didn't think it was going to be this easy. This is way easier than we anticipated. So the costs have started to decrease. So it is that chicken and egg, hence why we're here today to try and introduce this to many other folks. The best practices guide is it's going to deliver a lot of information to the industry and to the market in general as to why this can work and how to make it work. But I'll get to that in a moment. So there are a couple of other questions, and there's talk of manufacturers, and FortisBC is technology agnostic, vendor agnostic. There's 2 or 3 GAHP providers in North America right now. There's Rober, there is Vicot, and Saleh, I think there's one more as well. What's the third one?
Yeah, so Rober, VCOT, and ANSI, or the SMTI technology, that are the,
Right.
in our view, to our knowledge, forefronts of the gas absorption heat pump technology. And there are other vendors and manufacturers that are entering into this space as well.
Very good. So is there a backup required? That's a question that has been asked in the chat. Again, I don't want to spend too much time here on all these. I'll get to them as we go. But the devices are excellent as a backup to a boiler system, as a hybrid system. I think that's what we've kind of come to the best place, right, Saleh? That's the real sweet spot for this technology.
Absolutely, especially in colder climates. And during our pilots, we saw great overall system efficiency if these systems are paired with a condensing boiler. So when it gets really cold, then the boilers are doing the heavy lifting, and the GAHP units are complementing. Obviously, that's not, you want to optimize that, but that's how you maintain an overall system efficiency that is optimum and maximized.
Very good. Very good. So I'm going to move to the next theme while I sprinkle in some of the questions as we go. So our theme 3 that we're going to get into, and this is your opportunity, Ali, to share with the audience your journey through this GAHP technology, and where you're at currently, how you got here. So I'm going to turn it back to you. Just give us an overview of your GAHP technology journey.
Great, thanks, Ted. Yeah, that photo that you saw, maybe we can go back to it. I can give you a little bit about information on that. So that's our innovative technologies team. We have a dedicated team within Conservation and Energy Management Department at FortisBC who identifies these new technologies and opportunities and pilots, runs the pilots. So this photo, I think, was taken in 2019 when we started the pilot. So you see the gas absorption heat pumps, 2 units, the Rober units on a rooftop. So that gives you a bit of a sense of the size of these units. And next slide, please. Yeah, so I divide our development journey into 4 phases. The first one was identifying the technology and the pilots. But really before that, question I get a lot is why Fortis started going down this path? Like, what triggered that decision? And the answer to that, the short answer is government policy. So in British Columbia, the provincial government is really at the forefront of decarbonization. And in Canada, very similar to the United States, energy is a provincial matter, or something that's handled by the province or states. So the provincial government has a lot of say, or they basically are the decision makers when it comes to decarbonization, government policy. So in British Columbia, the provincial government published a roadmap called CleanBC Roadmap, where it signaled all the decarbonization pathways and government policies that wants to see happening in British Columbia from now till 2050 or 2030. So that Clean BC roadmap, it's publicly available. And when you look at that, you see that the government is really looking to transform the space and water heating industry and requiring all space and water heating systems to be at least 100% efficient. That isn't a sort of legislation or requirement yet, but that's the signal to everybody that with space and water heating, everything has to be at least 100% efficient by 2030. So as a gas utility, when you look at that, you get a clear signal as to where you're headed. So we started, in 2018, 2019, we started looking at opportunities or technologies that can be compliant with that policy. So we identify gas absorption heat pump. Our innovative technologies team started, piloting the technology. So we started with 14 Rober A units, and we installed them at 7 commercial sites across BC, primarily serving domestic hot water needs of these sites. And we did a complete measurement and verification on these 7 sites. We gathered the data. We worked with our partners to go through the data, and then we went to the second phase. Using the data, we developed an early adopter offer for our select FortisBC customers. Initially, we started with 18 sites, and we went down to 13 sites because we really wanted to find a sweet spot for these units and for the technology. Primarily commercial and institutional customers in our service territory. And we gave them a generous offer. We said we're going to cover 75% of total project cost, up to $200,000 in incentive, that's Canadian dollars, to really promote the technology and help these pioneers of the technology to go and give this technology a try and implement the technology. In return, we said, we want you to work with us in developing case studies, testimonials, and more M&V if we need to do that. I'm pleased to share with everybody that by end of this year, we're going to be completing 6 sites. So 6 sites will complete as part of the early adopter offer, and the rest of them, we're working with them to implement and finish the projects in 2024. The third phase was really opening this up for everybody in the province. So we developed and offered our prescriptive offer. So that's something that's available for all commercial customers of FortisBC, and we partnered with CLEAResult to help us promote the technology and provide education and training on the technology. And that's our phase 3. And phase 4 is really going beyond gas absorption heat pump technology and focusing on other types of gas heat pumps. They're engine-driven heat pumps. They're commercialized products that are out there that are utilizing other technologies and thermodynamic cycles, and they're gas heat pumps. And we want to focus on those to bring them to the market and provide incentive for those systems as well.
great, Saleh. Thank you. And I know you've got a couple more slides on the current offering. I'm just going to throw out one of the questions that right at this point, and you guys have also done some pilots with residential. And one of the questions that's in the chat is, are they beneficial in the residential space? And maybe you could share some of that information.
Absolutely, great question, Ted. So my area of focus is commercial industrial. That's where, that's the area I oversee. But I do know that our residential program team is working with our innovative technologies team, trying to pilot the residential products utilizing the gas absorption heat pump technology, working with manufacturers to do the pilot. Pretty much similar journey to commercial GAHPs, doing the pilot for a residential gas absorption heat pump units. So our residential team and innovative technologies team are actively working to do a pilot on residential, or number of pilots, and then create and develop a program for our residential customers. So that's definitely an area of focus for us, for sure.
Very good. No, I thank you. Another question that we always get asked, Saleh and Ali, and ammonia. The legality of ammonia. Ali, I'm going to turn this one to you because we get it every single session. Maybe you could speak to that.
Yeah, so this system runs on a mild solution of ammonia and water. So the quantity is for the units that you see on the picture, it's about 14 pounds of ammonia water mixture. It comes in a sealed.
Yeah, self-contained.
So the installer or the operators never have to come in contact with the refrigerant. It comes pre-charged, the unit. And because it is outside the enclosures, it's not an inside the building install. So even if there is a leak, which we haven't heard any incidents of from the manufacturers, if there is a leak, this refrigerant will evaporate. So the safety requirements are not complex at all. In fact, we don't have to pull a refrigerant permit while installing it either. So it's been pretty straightforward.
Very good. Saleh, anything you want to add to that conversation? I know you get asked frequently as well.
Yeah, no, that's a great question. Definitely an area of concern for some folks when they hear ammonia. So if I'm not mistaken, the Rover A units have 15 pounds of ammonia and 22 pounds of water. So that's the mixture. So and as Ali mentioned, the units are located outside, adjacent to the buildings or on the rooftop, and it comes pre-charged. So it's the whole mixture is sealed within the box. We see ammonia as a refrigerant in ice rinks. Obviously in Canada we have a lot of ice rinks. So when we are working with and talking with our commercial customers, especially the facility owners and their facilities teams, they get it. They understand the system. So usually we get the question about the refrigerant, but yeah, no concerns so far.
It's never been, the permits haven't been pulled or anything else.
No.
If I can just move to the next slide. Before I do, there has been a tremendous amount of questions and really good questions in the question box. If we don't get to your question today, we will be responding to everyone's questions after the session. There may be too many, like literally there could be that many questions. Obviously, there's a lot of interest in this technology. We're trying to stay at a high level, and we've got a couple more slides that we're going to get through, and we've got a good amount of time to answer as many questions as we can. But the next slide I want to take you to is for Saleh to answer and talk about the funding where you're currently at.
Great. So what you're seeing is the prescriptive offer that we first launched in June of 2022. We offered feasibility study funding as part of that prescriptive offer that is very unique. We don't have any other prescriptive or product rebate offer that has a feasibility study funding component to it, simply because we understood that customers need to take their time to do their due diligence, to really give it a try and see if this technology is a fit for them. So we offered up to $20,000 in feasibility study funding with no strings attached, meaning the customer used that study funding to study the technology for their site, and ultimately, for any reason, decided not to go for an installation. We wouldn't penalize the customer. They use that up to $20,000, and that's it. And the scope of that feasibility study includes energy study, structural analyses, if the customer is thinking about putting these units on the rooftop, anything related to the GAHP technology implementation. So we are flexible with the scope of that feasibility study. That's intentional. That's why we are not calling it an energy study. It's a feasibility study. And then the first version of the prescriptive offer focused on end users, and we provided $10,000 per unit of gas absorption heat pump, and some bonuses if the customer served multiple end uses with the technology. We had that was the first version. We got a lot of comments about this version, and that's why we thought we can simplify this further and make it more relevant for our customers, increase the incentive. And that's why in August of this year, we updated the version or the incentive, and we essentially matched it with the early adopter offer, where we provide 75% of total project cost up to $200,000 Canadian for our commercial customers. And the reason for that was, we really got great feedback on the early adopter offer. We realized that everything is now costing more because it's a new technology, and with inflation and everything that's happening across North America and around the world. And so far, we are seeing great response from the industry about this update, and that's something that is currently available for our commercial and industrial customers, and we'll continue with this offer into 2024 and beyond. So that's the update that was provided and was done on the gas absorption heat pump prescriptive offer at FortisBC.
Saleh, I understand your study funding has grown exponentially in the last quarter of this year because of this new offer. You guys are seeing quite an engagement, and with the training efforts that we've been doing. But maybe you want to speak to some of the study activity that you've had, success that you've had.
Absolutely, yeah. So the study component remains the same. So we continue offering up to $20,000 in feasibility study for customers who want to look at this technology. And we're flexible in allowing other technologies like dual fuel hybrid systems, engine-driven heat pumps, even electric heat pumps to be included within the scope, simply because a lot of customers want to compare multiple options and see which one is really a good fit for them. As long as the gas absorption heat pump is meaningfully studied and analyzed as part of the feasibility study, we approve the $20,000 feasibility study, and that's a really a great pathway for our customers to start their journey learning more about the technology and considering the technology, and ultimately getting into capital upgrades and getting that 75% up to $200,000 incentive for the implementation.
The other thing I think you've witnessed is the number of engineering firms picking up the effort in offering the studies on it. Like, we were at one when we first started, and I know there's several more that have now jumped on board and are offering the studies as well.
Absolutely. I think we can talk more about that education and training, the collaboration between FortisBC and CLEAResult. That's definitely it. You know, we realize that there's this need for education, training, and awareness for facility owners, customers, energy managers, and energy consultants and engineers, the designers of these systems, and ultimately the contractors and installers of the technology. So in 2022, we partnered with CLEAResult to collaborate on education, training, and awareness to various groups and stakeholders on gas absorption heat pump and promoting FortisBC's rebate offers and programs for the commercial sector. So the scope included hosting seminars, trade shows, webinars, dedicated training sessions, lunch and learns, and more. And one particular event that was a great success was on May 16th of this year. That was an in-person conference and trade show in the Lower Mainland in Surrey, BC, with more than 170 participants from around the world, from Europe, from Canada, from North America, from States. And later on, I heard from multiple folks that this was the first of its kind in North America. We never had this kind of conference or trade show focusing on gas absorption heat pump technology. We had a trade show component. Manufacturers brought their units in, so participants could see them, touch them, ask questions from the manufacturers and their representatives, while listening and learning from FortisBC and CLEAResult, and the partners that we work with, contractors, and the panelists that we had, and customers, learning more about their journey, their experience with the technology, and the projects that they have actually implemented in British Columbia. So that was a great success. And we're hoping that we continue that collaboration with CLEAResult, going into 2024, and expanding the education and awareness. And that's something that we're focusing on as well. Maybe I can go to the next slide.
Well, and this brings up my next point. The catalyst to all of this was the foundation of developing a best practice guide. And you've got the author of the guide on the session, Ali, and the overall approach for this whole session was to answer questions. We worked with the manufacturers. Ali worked with the projects that have been done from the early adopter. And I'll let you speak to it, Ali, how you got to the place of the best practice guide. I'll let you speak to that.
Yeah, well, firstly, I want to clarify that I'm not the only one who wrote this. So we went to a lot of people, and it's a contribution from a lot of smart people who put in their text and thoughts into it. But yeah, when we started looking into, when we were first approached to do this, I had a lot of questions. Everybody had a lot of questions about what is this technology? How does it work? Would it really be suitable? So we started talking to manufacturers. We went to contractors, consultants, everybody in the value chain of the technology, and started making a list of questions that need to be answered. And they were questions that we had ourselves. So we started researching the answers. A lot of it was based on the outcome of the pilot projects, the M&V, the data, the consultant that worked with Fortis, BES. We got a lot of their help on answering some of these questions. And then really responses to those questions kind of made into this guide. So a lot of the questions that I see right now on the Q&A box are also answered there. So I encourage everybody to go and look at this document. It's easily searchable on Google, and yeah, it's been quite a journey, that I can say.
So, Ali, there's one question here that you might be well placed. and it revolves around ROI. Is there a typical or a rule of thumb for return on investment on one of these types of projects? Has it been, I think it's a longer ROI than a typical project, but if you're forced to go to 100% efficient, good luck with that. I'll turn it to you.
Yeah, it's pretty long because I think there's the cost of the equipment. That is one component, but then what we've seen is that cost is just 20% of the overall project cost in most cases, depending on the application where you're trying to put in. There's a lot of installation costs that can be involved. So some of the projects, and we've been to one of those sites last month that where there was not enough room in the mechanical room of a school site that we went to, and the contractors had to do a really great job in making that room, making a lot of changes. So that kind of shoots up the project cost, even though the equipment cost is the same regardless of you putting it outside or on the roof. If it's on a roof, you have to crane it, you have to do the structural analysis, and that changes the cost as well. I think Saleh can speak to the rationale for increasing the rebate offer as well. I think that's also linked with what Fortis was seeing in terms of costs.
Absolutely, yeah. So one of the primary reasons that we significantly increased the incentive amount was exactly that. And from our perspective, where we want to have that ROI is between 3 to 5 years with the incentive. So that we gathered a lot of information from customers and consultants and contractors implementing or knowledgeable in this area. We collected that information and we tried to update our incentive program to help customers land within that 3 to 5 years return on investment. And so far, we are seeing great success, great feedback.
Very good.
And if I may quickly add here, one of the feedback that we got from the contractors is that as they're learning more and more about the technology, as they've gone through that cycle of putting in a few of these projects, they are expecting the costs to go down because they were building in that cushion for the uncertainties on dealing with the technology, which now they're more clear about. So that cost is also going down.
A question that we've gotten pretty much every single session we've hosted is the burning of natural gas. And, you know, this technology is consuming gas. You're burning natural gas. California, Washington, several jurisdictions are banning that. And Sally, I'm going to let you speak to it, but there, in almost every case, there is a place if there is grid constraint. And I know this was one of the factors for you guys at the very beginning. If we are grid constraint in an area, how do you go electric on everything when we're already grid constrained? And where does that leave you with future electrification in those areas? EV charging in buildings, but my service isn't going to be able to handle doing all my heating, doing all my electric cars, doing all of my cooking, everything. This is kind of got a sweet spot, and you're still greater than 100% efficient. But I guess to Saleh, is there any thoughts on the burning of the natural gas component?
Great question, Ted. Yeah, so that's exactly why I really want to start my presentation with those 4 pillars of clean growth pathway, because this energy efficiency and gas absorption heat pump is just part of the puzzle as to how Fortis is really looking at decarbonization, supporting our customers. So we are investing in energy efficiency and conservation. In addition, you know, we're looking at expanding our renewable gas offerings. So these things go hand in hand. And one thing that you mentioned is, yeah, I think Ali mentioned that these systems are compatible with a blend of hydrogen, I think up to 20 or 25%, depending on the manufacturer. So that's definitely a pathway for these systems. And to your point, Ted, yes, absolutely. This is not the silver bullet, and in our view, electrification is not a silver bullet. These are all tools in our toolbox to help decarbonize, and depending on your situation, you see which one is most cost effective and most relevant to your needs. And one example I can give you is a hospital in the Lower Mainland, in near Vancouver, wanted to electrify, and at the same time they wanted to add to their MRI section, MRI machines. So obviously, as a hospital, you have to prioritize the MRI machines. So they did that, but then they realized that there's no electrical capacity left for any other electrification. So although they really wanted to use electric heat pumps, they couldn't. So they came to us, and we explored the opportunity and viability of gas absorption heat pump, and they're actually going ahead with the technology, implementing that in that hospital. So that clearly gives you an example of where electrical grid constraints can be a challenge for customers. And what I say to our customers is, don't think no action is an option. If you can't electrify, then there are definitely other pathways, viable pathways for you toward decarbonization.
Thank you. Guys, I'm just going to tell you, as panelists, we have so many great questions to get through at the end of this thing. It's fantastic. We've really hit a chord today. I'd like to move to the next slide and talk about the Center of Excellence, Saleh, and maybe you could share what's going on here as well.
Yeah, before talking about this, which is very exciting, I just want to mention that Best Practices guide is available on FortisBC's website. So if you Google GAHP guide, I think it shows up. If you go on FortisBC's web page, on the rebate page, if you scroll down under answering your questions about gas absorption heat pump, there's a hyperlink with an access to the guide. So that's another way of accessing it through FortisBC's website. Yeah, about Center of Excellence.
Everyone that's attending today will get a copy of the guide too, right? I think that was our plan, is we're going to email a copy of the guide to everyone attending today.
That would be awesome. Yeah. So very quickly about Center of Excellence. The University of Fraser Valley was one of the early adopter participants in our early adopter offer for gas absorption heat pump. And we realized that there is opportunity to add to the scope and make a training and demonstration facility out of that installation. So we started collaborating and talking to the University of Fraser Valley, which is not that far from Vancouver, and maybe an hour and a half drive from downtown Vancouver, to utilize their Trades and Technology Center to showcase the technology. And the primary reason for that was we wanted to have a training and demonstration project, a real project in operation with full MNV with TV screens, showcasing the real performance of the system, and be able to bring in stakeholders, for walkthroughs, for education and training purposes. And that I'm really glad that I can now share the news that this is happening. So the University of Fraser Valley is implementing the technology right now. They've passed the design, so the design phase is complete, and they've ordered the equipment, and they're working with their contractor and designer to implement the technology. So we are really excited about that. And to my knowledge, it's definitely first of its kind in Canada, or maybe in North America, to have a dedicated real system available for showcasing, for training, for walkthroughs, to bring in delegations, of government policymakers, engineers, consultants, and contractors, and customers, facility owners, to really see the units and see them in live performance, and monitor their performance, with the TV screens and whatnot. And so that's where we are with that project. We are excited about it. And we want to, after that, we want to take the next step and work with the University of Fraser Valley to focus on further education and training by way of developing courses and certifications on gas and electric heat pumps to really promote heat pump technology in general in British Columbia.
Very good. So Saleh, there's a bit of a trend in the questions on TRC, cost effectiveness of the program. I might take some of those questions offline. And then some utilities in the chat are also making mention that they're having troubles getting anything gas implemented in their territory. What would you say to those utilities that are struggling with gas measures?
Yeah, so the cost effectiveness obviously it's top of mind as a utility, running utility incentive programs. Thanks to our pilot activities, we had really robust and accurate information about the performance and cost and savings, gas savings as a result. So we used all of that data to be able to run our cost effectiveness tests and develop the program. One thing I would highlight, and it's related to government policy, and it's impacting us as a gas and electric utility in the province, is that the province of British Columbia has amended the DSM regulation, which governs all the incentive programs and everything run by utilities, and we are shifting from TRC to utility cost test UCT, using avoided cost of renewable gas, and that required a lot of conversation with the province, with the Ministry of Energy, to get to that point. So my advice to other utilities in North America is to engage with your policymakers and have that dialogue. Make sure that you have all the policy tools in place to so that they enable things that you want to do through policy and regulation. So that shift from TRC to UCT using avoided cost of renewable gas gives us a lot of bandwidth and opportunity from cost effectiveness to incentivize not only gas heat pumps, but other advanced DSM measures like hybrid dual fuel systems, things that do not typically pass that traditional TRC cost effectiveness.
Great. Saleh, fantastic. Folks, guys, I think we did it today. We've hit time. There's still a ton of questions we've got to get to. We will get to all of these questions. We'll reply back after the session for everyone that's been in attendance. I think, Saleh, you are going to be a busy guy. I can tell you that. You're going to have lots of inquiry. Ali, maybe you and I will get busy as well from a program perspective. We've got the nuts and bolts on how to do this. We know how to make it work and educate in a given market. That's probably the biggest thing I'll close with, is when you do the proper education and help the engineering community and the contractor community, and then ultimately the facility owners make those decisions, you can help as a utility, you can help with that. So on that note, I'm going to close the session. Thank you everyone for your attendance today. It's been our pleasure to present to you and help take you on your journey for the gas absorption heat pumps. All the best, everyone.
Thank you.
Thank you.